What's going on here, guys? Messing with the system in high power mode, consuming 30 watts. The transmitter's consuming 30 watts through that DC board. 85 volts at 0.356 amps. Interesting thing is if I take a reading on the input cap, and the input cap is in parallel with the output caps that go to the solar charge controller, so the whole system can recharge itself. The interesting thing is I get a different voltage reading at the input cap versus the output caps, which doesn't make any sense because they're both in parallel and the connections are good and the system will still recharge itself. But the interesting thing is my voltage here is about 13 to 13.15 when I shut the system off, because having it under load does strain it a bit. Now I shut the system off, it'll stay at about 13.15. As you see, it is off. And I turn the system back on. It again consumes 30-ish watts, and we're in high power mode. So under load, it drops to that. I think because we're so close to the source battery, I mean not the battery, the source supercap, I keep calling them batteries, that it drops a little under load, but it will maintain itself. I built this thing, I think it was, I forgot the exact date, but it's been going for like 10 days now, 10 or 11, where it completely runs itself. Doesn't need any form of external input except for an earth-ground connection. The external input to the device is the earth-ground connection, or it could be a large metal plate or body in capacitive coupling with the earth. So that's where the power gain comes from. We fluctuate anywhere between 13 volts and 13.1 or 2. The system never drops below 13 volts. So I'm basically just fine-tuning it, and I discovered if you put a battery up here next to the transmitter, the battery will act as an antenna for radiant energy. So we're not using this battery in the normal way at all. Like we're not even drawing power from the battery. What we're doing is we run one wire, and I showed this in my most recent video, my last video. I run one wire from one terminal of the battery to the AC side of a bridge rectifier made out of 1N5817 high efficiency Scotty diodes. So one AC side, so the negative of the battery goes to the rectifier. The other end of the rectifier goes to the negative of the supercap. So you see what I'm doing? I'm splitting the negative and I'm splitting the positive. So again, to sum it up, the negative of the battery goes to a bridge rectifier, and the other connection goes to the negative of the supercaps. In between those 2 points go to the AC side of the bridge rectifier, and from those 2 points we get a very high power output. And I basically just duplicated that circuit, and then I went from the positive of the battery to a separate bridge rectifier to the positive of the supercaps. And what I do for circuit isolation, because this wireless power seems to flow right through capacitors no problem, and it causes circuit isolation. So if you put just a regular capacitor in series before you connect it to the positive of the supercaps or the negative of the supercaps, it will give you circuit isolation, which is good, which you should do. So basically we're splitting the positive and we're splitting the negative, and that battery is not being used in any way except for just a receiver. The plates in the battery act as a receiver of wireless energy. We are not drawing power from that battery in any way. We are simply using the plates in it as a wireless energy receiver. So again, to sum it up, it goes from the negative of the battery to a rectifier. Other end of the rectifier goes to the negative of the supercap, and we have a DC output from that rectifier that goes between the negative of that battery and the negative of the supercap. And I just did the same thing on the positive. So, and you can isolate the circuit with a capacitor. Looks a little messy. It's not messy at all. I was doing experimenting, further refining the system. As you see, I'll shut this off. The system just never loses a charge at all. And if I were to take this meter reading here, it would say like 13.3 or 13.2. Again, I'll turn the system on. The system just never loses a charge. I've never seen it drop below 13 volts. The other interesting thing is I still maintain all the phenomenal radiant energy effects even at distance. And I could make energy extraction circuits further away if I wanted, and then run the output back into the system and have it self-sustain itself even more. So this system as it is completely self-sustaining. I'm not even sure if I should patent this. It's all in the PDF how to design it. This updated circuit I'm going to add, it's literally just a battery sitting up here, and the plates in the battery act as a receiver for the radiant energy. And again, we're not drawing power from that battery in any way. We're simply using the plates in it as energy receivers. I could, if I wanted, utilize that power somehow, but right now I'm just using the plates in it as energy receivers. Again, I'll shut it off. And this thing has been under constant load between 15 to 30 watts for about 10 days, and the power has never dropped below 13 volts. And look at that, boom, rock steady. 13.16. The thing never loses power. 13.17. Back on. I will run a load from my inverter. That's a 40 watt bulb. This was the 6 watt LED I ran yesterday. As you see, we are drawing 40 watts. Well, 33.7 to be exact, because as the bulb heats up, it draws less current. So we're running this load, no problem. I already have some more components on the way to make it even more efficient. We're on the AC side now, which is going to get fun. I'm going to get an even more efficient charge controller than this that boasts 99.98% efficiency, high-end MPPT. And this system, we really want to squeeze even 0.1% efficiency out of it if we can. Every little bit adds up to make a system that's more than the sum of its parts. So I'm going to do that, spend a little bit of money, and get everything as efficient as possible. Put all the parts list up on the PDF. And if you want to build a high-end system, you'll be able to. It'll run itself. It'll cost you probably about $1,000 to build. And if you follow the guide slowly and closely, it'll completely function, no problem. It'll run for months at a time, or in weeks at a time, and also produce excess power. Obviously, I only built the system about 10 or 11 days ago, and I've never once had to recharge it. And so I can't tell you if it can last a month or not, but from what I've seen so far and what I've been doing and have it constantly on, because my amp hours total to 24 amp hours with all these capacitors, 24 amp hours at 13.8 volts full charge. That's like 582 watt hours, I believe, is what it calculated to. But anyway, you wouldn't be able to run this thing without it dropping in power the way I've been running it. So, like, these super caps are light. They're very light. All 4 of these probably weigh half the weight of that battery. So, I'll show you that load running. The system will drop in voltage from the load that's running, because what we're doing is we're taking power away from the system. This was the simplest way to do it. The solar charge controller recharges the input battery and the input caps and the output caps. I keep getting the term battery and super caps mixed up. It is driving me crazy. So, shut you off. We'll watch the system recharge. Almost immediately back to 13.1, 13.2. And I ran that 40 watt load for like 3-4 minutes. And it's more telling over here on this meter. And it will recharge itself back up to 13.05 slowly. So it's a completely self-sustaining electrical system. The gain in power comes from an earth connection. That could be technically considered your external input. That's where the device gains its extra power. It gains its extra power from a ground energy amplification effect. You can even ask Chat GPT this, Chat AI, whatever. Completely reasonable to build these systems. Nothing magical, nothing hoopla about it. Nothing that violates the conservation of energy. No reason why it can't work. It's similar to a heat pump type effect where you can have a 600 or 800% efficient heat pump. And yeah, it's also called parametric resonance or parametric oscillation, where when a resonant receiver coil is in perfect tune with your transmitter and earth grounded through a series capacitor to avoid detuning, it will not place an electrical strain whatsoever on the transmitter. All complete science. So the universe gives us everything we need in abundance. Humans just have to stop being so greedy and figure out how to engineer things in accordance with nature and natural law. I've been working on this system for 5 years. Only recently I've been taking it very seriously, having the most major breakthroughs lately, and I'm very thankful to you all for that. I couldn't have done it without the support of all you guys. I couldn't have done it without the support from the Patreon, the parts donations, the commercial company accounts I have, the people who keep telling me to keep pushing for it, keep doing it, you can achieve it. The fact even ChatGPT says it's possible. And it can work without violating any conservation of energy laws. Which is amazing. And this system works 24/7. And once started, it runs indefinitely and recharges itself. As long as you have a very good earth connection. And I simplified the earth connection to only need just one. Not two anymore, just one. So as you see, he'll slowly recharge. And for those of you that don't know, you can't usually draw 30 watts of power from a 24 amp hour super cap bank while it still recharges itself. That's unheard of. This would be draining very rapidly if I did this in the traditional way. The system returns its energy like a cyclotron. So if you design a system for 500 or 1,000 watts, you can run 500 or 1,000 watts for a short period of time, maybe an hour or two, and then you shut that load off, it'll recharge itself. And then you can run that heavy load again for a time, shut it off, it recharges itself. And there you go, it's almost at 13.03. So, supercaps don't usually recharge while you have them under a 30 watt load. And I have a lot of people telling me too, like online, there's a lot of trolls like, oh, you're faking it somehow. It's like, no, I'm sorry. I have videos where I even set this up working in my yard, in the middle of my yard. I have a 5-acre farm property. Like, there's no way in hell this could be faked. So, if you don't believe me and you think it's faked, ask ChatGPT if this is possible to engineer. So, as for the trolls, I don't care to entertain you. I've devoted 5 years of my life to this work. The first 2 years, I didn't really take it seriously. It was more just as a hobby. And then I started to discover serious things. And then I started to take it seriously. And the aid of ChatGPT and the community was phenomenal. Like, ChatGPT really helps with the advanced mathematics and the tuning. It's a very useful tool to have. And forgive me, I have bad allergies. So, and if I shut the load off, it'll probably be at like what, 13? Yeah, see, it's almost at 13.15 again. Back on. So, yeah, basically that's how it works. That's the science behind it. Nothing fishy about it, nothing hoopla. I've reached out to other major YouTubers about this system. They won't even acknowledge me. It's like they're, I don't want to say maybe they're involved with big companies somehow, but it's like they don't even want to touch the topic. But we have a fully working system here, and only a long amount of time will tell if it keeps its charge at 13.15 volts at this end. And for some reason, this end will always say 13.1 or 13.2. I'm not sure why that is. Sometimes I'm bad at explaining things when I wake up because of my bad allergies. But anyway, that cap bank is in parallel with this cap bank through the solar charge controller. So when the receiver coils are on, the whole system can recharge. It's that simple. And it looks a little messy here. It's really not. It's just the rectifier circuitry that goes between the positive of that battery and the positive of the supercap, and the negative of that battery and the negative of the supercap. And if I were to take a voltage reading on that battery, it would be full because we're not using that battery in any way. We're just using the plates in that battery to receive wireless power. So that's how that works. Bet you if I turned it up even more, it would recharge quicker. We'll do that. I don't really like going past 35 watts because I need a bigger heatsink. We'll go to 90 volts on the input. And the harder you drive this system with voltage, the more efficient it becomes and the wireless field gets bigger. So in theory, if we built this system huge, we made much bigger coils, you could run a freaking house off it. Like there's no reason why you can't. You could run a house off it for a few hours. House would shut off, the system would recharge itself, run the house again for a few hours. And you could even cycle it, build 2 or 3 systems. Okay, that one's got to recharge, then the other one switches on. And then when that one's recharged, it switches back to the other one. You could have 2 or 3 and it would constantly switch between them. And I also noticed too, there's like sweet spots. If I put it to the point where the system consumes too much power, it won't recharge. And if I put it to the point where it's just about perfect, it's in like the 27 watt to 30 watt range is where it will recharge very noticeably. Right about there. And if I turned it on high power, I'd probably have to adjust the distance of my receiver coils and that battery, which is acting at the plate as a receiver. So again, I'll shut that off. We will see our charge. 13.14, just about 15. It will probably say 15. Yeah, 13.15. The system never loses a freaking charge. So, and in case you haven't known, this has been going on for about 17 minutes now. And if this was doing stuff the traditional way, that would not maintain a voltage of 13.15. So that's how that works. Nothing fishy about it. Nothing hoopla, magical. It's just science. I will turn the this 40 watt bulb on again. Hopefully you can see that this is 40 watts. I'll turn that on again. And we will watch that recharge once I shut the load off. And keep in mind, this has gotten very exciting. I can probably get another 10 to 15% efficiency out of this system. Higher end charge controller, a little pricey but worth it. Very high end efficient inverter. Like, again, 98 or 99% efficient. I will buy. So I'm going to upgrade the charge controller, upgrade the inverter. And when I'm on the AC side, I'm probably going to use an isolation transformer with a resonant cap on the output. So that output of the transformer will kind of form a decoupling effect and use even less power from the inverter, which is something to think about. Things get exciting when you're on the AC side. You can do a lot of fun engineering. And I'm going to get the purest 500 watt sine wave inverter I can get, highest efficiency. I'm probably going to want to get one more of those super caps, put it right here, even though they're what is the price? I think it's like $120 a piece or something, $125 a piece. They look a little sketchy. They come from Brazil. As you see, it's a 14 volt DC, 3000 farad super cap, 81.6 watt hours per one, with a built-in BMS, so it can't overcharge itself. And yeah, again, I'll shut the load off. We'll see the system recharge itself. and within like 5 or 10 minutes it'll be 13.05. As you see, it wants to lock at 13.01, locked at 13.01, and then gradually it'll just go up to 13.05. And I've been pushing this system very heavy the past few days, using it a lot, so that's why it's a little slow on the recharge, but it still does recharge. Now it's at 13.1 soon. I mean 13, it'll say 13.2 soon. 13.02. Yeah, and again, if we were doing this in the traditional way, you usually can't run a 30-watt load with only 24 amp hours of capacity for very long without it draining. So I'm proving here undeniably through these duration tests the system is completely self-sustaining. It recharges itself. I've charged my phone off this output. I've charged my phone from the USB output of the charge controller and the USB output of the inverter. I've also charged it from the AC output of the inverter. But there's not really a point in doing that. Why would you go from DC to AC to DC again to charge your phone? Just plug the cable into the USB port. So that's going back up. I'm going to try and design the future system to be extremely fancy. It won't sit on a wood board, because the wood board, I found out, actually absorbs some of the wireless power. I'll probably put it on a big piece of acrylic. Everything will be nice and neat on the future version. All the components on this board are probably about $1,000 total. A little over or under. The super caps were the most pricey. There's about $650 worth of them sitting there on the board, plus another $50 in shipping. And you don't need this many in your system for it to work. You could use just one, or you could use a traditional battery. A nickel metal hydride battery would be the best, the one with no memory effect, or a Lifey PO4 battery, from what I heard. The only reason we use the super caps is for the rapid recharging and the fact they don't degrade over time like batteries do. I also put the super caps in my system because I didn't want people to say, oh, you're having weird VI curve effects from your battery. It's like, no, they're not batteries, they're super caps. And it wants to lock at 13.02 soon. It is locked at 13.02 now. As you see, it wants to go to 13.15. When I shut the system off, it's almost as if the system completely recycles its power. And there we go. So, the system has been running non-stop 10 or 11 days now straight, while also running loads for periods of time with the excess power. And look at that, 13.1. So, I'm proving undeniably to you all the system is self-sustaining. And I move that in videos. This is the only spot where AC power comes into my room for this area. We're not using anything here. This is my bench supply. This is my power bar with a watt meter. This is where the bench supply plugs into. There's only one connection going to it, the power supply. I just keep it up here because I keep throwing it on the bed. It's getting annoying to move, but as you see, everything is off. Nothing is on. We're not using anything on the AC side. There's no hidden wires anywhere. People who don't believe me, you can talk to the people who've replicated it, and you can also You can also come over and look at the system if you're near close enough, and I'm home. As you see, it's almost as if the system returned all its energy and used no power. On again. Keep it right. When it makes that high-pitched ringing sound, I noticed, is when it's in the most recharging state. You can hear that now. Now it's at 13.06. So 27 watts on the input seems to be its sweet spot. 27 or 28. So I like making these long videos. They serve as a video diary journal for me to go back in time and look at them. And I'm also doing improving duration tests of the device. As you see, there's no hidden wires anywhere. And I'm getting a phone call. I'm gonna have to answer it real quick. Hold on.